So in today's lecture, we are going to see what is a truss. By definition, a truss is a structure that is made up of straight, slender bars that are joined together at their ends by frictionless pins to form a pattern of triangle. That is, when we say that truss is there, the basic formation will be a triangle. Okay, then the loads act only at the joint and not on the member. Thus, every member of truss is identified as two force member. So first of all, we will try to visualize how a truss looks. See, a truss is made up of straight slender bar. Therefore, there will be some slender portions there. Let's say this is the first member, second, third, then member number 4 and member number 5. Okay, these are nothing but straight slender bars and they are joined together at their ends by means of pins. Okay, the joints are pin joints or hinge joints. Okay, the joints that allow rotation but not horizontal or let's say sway or vertical motions over there, that are pins or hinges. And the truss is supported at its end, or there are some end support, either of which may be a pin support, another one may be a roller support, or the truss can be a cantilever one, or the truss can be a fixed one. Okay, so by definition we are looking at a very diagram of truss where there are members. Okay, and see, now we have completed a truss diagram. You can see triangle number 1 is there, triangle number 2 is there, and triangle number 3 is there. Now where we have seen truss, see, if you see any industrial shed or let's say parking of our college or let's say canteens front, the roofing structure on the canteen area or let's say the roofing structure in the parking lot is made up of truss. Okay, the GI sheet is placed over a structure looking like this. This is nothing but a truss. Okay, see, this is the roof of GI sheet. Then the roof is placed over this skeleton assembly, and this skeleton assembly is called as a truss. Okay, so summing this discussion up, what we are ending up with, truss is made up of slender bars. The joints are pinned ones. Okay, the joints are pinned, or let's say hinge, means whatever rotation, whatever slight rotation that the member may experience, it is allowed by that pin. Okay, the supports may be hinge or roller or fix. Okay, and the members are two force member. We will later on see what two force member is. For a while, remember that the load act only at the joint. Okay, whenever we are analyzing truss, whenever we are saying that truss takes load, then we are visualizing that, we are assuming that whatever the load that is coming onto the truss is coming on the joints only. Okay, now let's try to see what are the various types of truss. Okay, various types, or let's say various forms. See here, there are several names associated with this truss diagram, that is a king post truss, scissor truss, prod truss, Hoover roof truss, sawtooth, Fink, Warren, and prod truss. See, the names or the tags or the titles associated with this type of truss are derived either from the shape resemblance that they are having. See, for example, the scissor truss is having some sort of resemblance with the scissor, that's why the name. And some of the names are derived from the locations they were first invented or the specific arrangement of member. For example, there is a king post truss and another type of truss is there which is called as queen post. Okay, presence of a king post makes the truss to be called as king post truss. If this queen post is present, then the truss is called as queen post. And the names, the differentiation, the variation is then useful to determine what kind of span it is going to serve. Okay, means with respect to the span it can serve. For example, if you are saying an industrial building is there, then the column position is like this. Okay, these are the two columns. Now in between the two columns we want to have some roofing structure. The roofing structure, the roof deck, can be supported by a truss, let's say. Okay, then what sort of span we have to cover? Okay, what is the length of span that we need to cover by using that truss is the deciding factor what sort of truss we will be having. Okay, for example, Pratt truss can serve a very much longer span than the king post or let's say scissor truss. Okay, king post truss and scissor truss are the simplest basic type of truss, whereas when we are looking at Warren or let's say Pratt truss, the span covered and the number of members in the Warren truss or let's say Pratt truss is more. Okay, the example, the perfect example of having a truss as your bridge truss is the Howrah Bridge, okay, in Kolkata. That is nothing but a truss bridge. Then the many bridges that we encounter while we are traveling via train, then the structure over there is the bridge truss. Okay, near Amravati the Revsa railway bridge is there. It is nothing but a truss bridge. In order to identify truss, it is very much simple. You will be seeing structure like this involving some members connected, joined together like this. Okay, this is how we identify truss. All right, now let's say what are the various applications. See, all the transmission tower, okay, power transmission or let's say the radio towers are there. The structure is made up of truss. See, the members you can see like this. Okay, and whenever we are looking at any truss, the basic shape that we are going to encounter every time is a triangle. Okay, not necessarily triangle must be there everywhere, but the basic unit cell of a truss, if we observe for multiple types of truss, the basic shape that you are going to see is a triangle. Okay, triangle means 3 joints and 3 member. Okay, then the Howrah Bridge truss we saw is another application of truss. Then as we were discussing, roof structure is made up of truss most of the time. Okay, the roof decking, okay, the roof decking is going to be made up of truss, and the roof covering is made up of let's say GI sheets. Okay, means when we say that a roof truss is there or let's say just roof, then roof has 2 components. Okay, roof deck and roof cover. Cover is the portion that blocks the rain or let's say sunlight or whatever the natural factors or natural component that we want our structure to be protected from. Then deck is the support system. Okay, for example, let's say this is a truss, then the upper layer, the opaque layer will be of roof covering. Okay, this will be the GI sheet covering like in our canteen, and the support system for that cover, the heavy cover, will be this simple truss. And the best world famous example for the truss is nothing but Eiffel Tower. Okay, Eiffel Tower is totally made up of slender bars joined together by means of nuts and bolts, and the basic shape here also you can observe is triangle. Okay, so this is the theoretical take, this is our theoretical take towards the concept truss. In the next lecture we will be looking at the type of truss based on whether it is a perfect truss or imperfect truss. Okay, when we are differentiating truss whether it is perfect or imperfect, we will have to look upon a formula which is m is equal to 2j minus r, where m is the number of member. Let's just write it down. M is equal to 2j minus r. This equation is the sole deciding factor to judge whether the truss is statically determinate or not determinate. Okay, whether we can determine the loads or type of load in the truss or not. See, why we are studying truss here. In engineering mechanics, in truss, we will be looking at what sort of load that is being put upon the truss and what will be the behavior of various members when the truss is loaded. Okay, see, and initially we said in the definition of truss that truss is a two-force member. Okay, therefore a pair of force will be there. It will be acting onto the member, and the two forces will either be tension force or compression force. Okay, now come back to the equation where we will be deciding whether a truss is perfect or imperfect. M is number of members, then J is number of joints, and R is number of reactions that a truss can have. Number of reactions. And reactions, when we are saying this word, the number of reactions will be Fx, Fy, and moment. That's why whenever we say M is equal to 2j minus R, we can simplify it. We can just write it as M is equal to 2j minus 3. And whenever we are given a truss and we have to determine whether it is a perfect or imperfect truss, just we have to count how many number of members are there. That will be the LHS. Then in RHS we will be counting the number of joints. Okay, if LHS matches with RHS, then the truss is called as perfect truss. Otherwise we declare it as imperfect, and the imperfect truss can be imperfect redundant truss where extra member is there, extra member will be there. And when we say the truss is imperfect deficient, the word deficient means something is lacking. Therefore the number of member, if they are less, if LHS is less than RHS, then it is called as imperfect deficient truss. If LHS, that is M, is greater than the RHS, then it is called as imperfect redundant truss. Redundant means something is extra there, or let's say a member is extra over there. This imperfect truss cannot be determined the usual conventional method that we are going to see in order to analyze the truss. Okay, so that is the initial, or let's say this is the introductory portion regarding truss. In the next lecture we will be seeing truss perfection or imperfection by using this equation M is equal to 2j minus R or M is equal to 2j minus 3, and we will be looking at the two force concept. Okay, so that's it for this lecture. We will see the next topic in next lecture. Till then, take care. Bye bye.